All right, guys. Today we are kind of kicking things off with a lesson on just some review of integer operations and Pemdas, which I'm sure a lot of people have heard of that phrase, or please excuse my dear Aunt Sally. Something that a lot of math classes do at the beginning of the year is just to brush up on those rules, make sure that we've got them down because they do come up in other subjects. So our objective for today is to review the main operations in math and to be able to use those operations in the correct order. I'd advise you guys to write down that lesson objective just about every single day. Now, first thing that we're going to do is we're going to take a look at the word integer and try and come up with a baseline definition of what the word integer means. So integer is the set of all whole numbers and their opposites. So integers would include numbers like -3, -2, -1, 0, 1, 2, 3, and so on. So basically any whole number that can be counted to or its opposite was considered an integer. And the word operation, this is an old French / Latin word that's from the verb operare, which means to expend labor on. So we're going to expend labor on or do some things to some different integers and numbers. So in math, a process in which a number quantity expression is altered or manipulated according to formal rules, such as the rules of addition, multiplication, and differentiation. We're going to talk about those integer operations today. Again, something that's not necessarily brand new to you, I would assume. Something that probably you've talked about going back until maybe even 4th or 5th grade, but it's a really important thing that we're doing things in the correct order and we're doing and computing accurately. So what are the main operations? I want you guys to take a minute to try and list some of them. The main operations in math, so the things that you guys have heard of. Now we can go way back to 1st, 2nd, 3rd grade. Addition is a very important one. We use it just about every single day. Subtraction, multiplication, and division. These are kind of the main four. All right. And when we deal in math, a lot of times we're going to add on these 2 extra ones at the beginning, which would be anything in parentheses. So we can group things or change the order of operations using these parentheses or grouping symbols. And then also exponents. We're going to talk about a little bit these 2 concepts today. So these are our main 6 operations that we deal with and try and get a little bit more practice with today. Why do we learn this every year? Okay, some people ask me, at the beginning of the year, say, hey, Neubauer, we learned about this in 4th, 5th grade. Why are we learning about it again? First thing is accuracy, okay? Basketball players shoot free throws every single year. They don't necessarily master it ever until they get to 100%. We need to maintain some accuracy and some consistency with how we compute, all right? These are also basic skills that allow you guys to acquire more complicated skills. For example, we get to the unit on slope and linear functions. We really need to be sharp when it comes to subtraction because you have to subtract negatives a lot. You have to do a lot of different computations quickly. Equations, if you understand really, really well the order of operations, solving an equation is just working in reverse, and we'll talk about that later. And this thing on the bottom, I really want to highlight this. You don't want your computation to cause you an incorrect response. You don't want the only thing that you're doing wrong in a problem to potentially be just your computation, and that's what leads to an incorrect answer. All right, so just a couple basic things, basic reasons in terms of why we talk about this at the beginning of the year. All right, so we're going to jump right into it. Rules for addition. I'm not going to spend a ton of time on this. We're going to kind of review the rules, talk about a couple different ways to do it, and then if you guys have some opportunities to practice this, you should have some opportunities today, you guys can do so. So we've got 2 basic ways we add, all right? We've got same sign addition where we're adding 2 numbers with the same sign, 2 positives or 2 negatives. And we've got different sign addition where you might have a mix of the 2. You might have a positive and a negative one. Okay, Miss Gatewood in 7th grade really has a nice song, that same sign add and keep song. You guys, some of you may have heard that or can maybe sing it in your head right now. And if you haven't, talk to someone in your class that actually has, because I'm not a great singer. I'm not going to sing it out loud. But really, really basically, we add the absolute values, keep the common sign. So if you've got 2 positive numbers, our answer is going to be positive, and we just simply add them together. 23 and 55 add together to make 78. -12 plus -9, again, 2 negative numbers. The signs are the same. We take the negative plus the negative. We just add absolute values. So we add 12 and 9. which gets us the number 21. And then we give it that common symbol of negative. So our answer in this one is just negative 21, all right? A really basic concept. If we add more negative to something that's already negative, it's gonna get even more negative, all right? Different sign addition. You notice here we've got a number that is negative plus a number that is positive. So that's how we tell that this is different sign addition. In this situation, we're going to subtract absolute values. Usually we go, or the rule is, take the smaller from the larger. Okay, so we take the larger minus the smaller, if you want to phrase it that way. In this case, the number 15 is our larger value. So we are just going to simply take 15 minus 12.5, do some subtraction. This should get us 2.5. And then we keep the sign of the larger value. So in this case, between 15 and negative 12, the larger value is positive. Our answer would be a positive 2.5. Again, not taking a lot of time on these rules because you guys have seen them before, just reviewing the rules. 18 plus a negative 12.1. When we simplify 18 plus negative 12.1, again, different sign addition, take the smaller from the larger. So we're going to take 18 and we're going to subtract 12.1. We'll try and do a little bit more complete here. So we're going to take the 7 and borrow from that, make that or the 8, borrow from it, make a 7. We've got a 10 here. 10 minus 1 is 9. 7 minus 2 is 5. And 1 minus 1 is 0. 5.9 would then be our answer. And when we take a peek back, we've got 18 plus a negative. The larger value is positive. So we know our answer is positive. All right. Adding a negative is literally the same as subtracting. So if you remember it that way, that helps. By all means, use that for your little way of doing things. Review of subtraction rules. Okay, if the two numbers are positive, pretty simple, just subtract them. Okay, 68 minus 29, we're going to use the standard algorithm for doing that. There's a lot of different ways that we can subtract, but we're going to subtract 68 minus 29. If you need to borrow, you borrow. Borrow from the 6, this is going to become a 5. This is going to become an 18. 18 minus 9 is 9. 5 minus 2 is 3. If the two numbers are positive, you just simply subtract. All right, positive 39 is our answer. 13.2 minus 7.8. Again, if you need to borrow, you borrow. It's important that when we're subtracting, we line up our decimal points. 7.8. This is a situation where we would need to borrow, so we're going to borrow actually, I think, twice. We're going to borrow from the 3. Becomes a 2, and we're going to borrow or change this 2 into a 12 and then do our subtraction. 12 minus 8 is 4. 2 minus 7, can't take it away, so we borrow again. This is going to become a 0. This will become 12. 12 minus 7 is 5. Our answer is 5.4, and in that case, another positive value. Now, the tricky part about subtraction is when you do maybe have some negatives mixed in there, and that's a situation where it's really helpful to add the opposite, okay? Because again, adding an opposite is the exact same thing. So we're subtracting 4, which is equivalent to adding negative 4. So this is how we would do this. The subtraction sign would just turn into a big plus, and then we'll add a little negative symbol to this. And now we refer back to our addition rules. If I click on the previous screen, same sign addition, I think, is what we would have here. So negative 3 plus negative 4, add and keep. We got 7 as our answer, and since the two numbers are negative, our answer is negative 7. We're adding more negative to this. Another way of thinking of it is if you're 3 below the water and you go down 4, now you're 7 below the water. If you got $3 to the hole in your lunch account and you spend $4, now you're 7 below. Another way of thinking of it. Subtracting negatives, 14 minus negative 6. Again, add the opposite. One little trick that I learned from a student is if you see two negatives in a row, you just connect them and make them one big positive. So this is equivalent to 14 plus 6, which is going to get us a value of 20. So some review on addition and subtraction. Now let's take some time to try it on your own. Pause the video if you need to. So we've got some basic 6 of them on the left-hand side and then some less basic ones on the right-hand side. You guys can choose which ones you'd like to do. If you want to do the basic ones, do all 6. If you want to do the less basic ones, do just 3 of them. As you can see, I'm not an English teacher. A, B, E. That's supposed to be C. So pause the video. All right, let's try these out. -12, -18 adds together 2 signs that are negative. We add them to keep, so this should be -30. 5 minus 11, add the opposite. Subtract 11 minus 5, that's 6. Larger value is negative, this is -6. -1 plus 2, close enough. We can do some temperature math. -1 degrees increased by 2, that's going to get us a +1. 4 plus -21, we're adding negative. Different sign addition, we take 21 minus 4, which is 17, and give it a negative symbol. 10 minus a -10, add the opposite. 10 plus +10 is going to give us +20. -15 minus a -30, again, a subtraction of a negative, so we connect those symbols if you want to do it that way. We do an addition, -15 plus a +30 should get us to +15. So if you did those 6 of them, those are your answers. The less basic ones, A, -2/5 plus -6/5. If we're dealing with fractions and the denominators are the same, we simply add the numerators. -2 plus -6 is going to get us -8/5. -2/3 minus 4/5. This is one where we would have to find common denominators. -2/3 is equivalent to -10/15. And -4/5 is equivalent to -12/15. And our answer in this one should be -10 minus 12, which is -22/15. Could reduce that to -1 7/15 if you'd like to. And the last one, 3.8 minus a -5.3. Connect the two. This is just like adding. 3.8 plus 5.3 should get us, let's see here, 8 and 9.1. So if you did the ones on the right, there's your answers, these ones. And if you did the ones on the left, here's your answers. Let's see. Now we're going to move on to some rules for multiplication and division. And the nice thing is that the rules are the same. Same sign. If you're taking 2 numbers and multiplying them together and they have the same sign, you'll always get a positive result. Always, 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 always. So in this case, we've got a positive value times a positive value. We just simply need to do the multiplication. Half times 52, right? Which is actually equivalent to doing half of 52. Should get us an answer of 26. All right, if you need to do it this way, that's fine too. 52/1 and multiply across, that's completely fine. But our answer should be 26. Next one, this is a -7.8 times a -3. Again, this is a negative times a negative. They have the same signs. Negatives times negatives will always equal positives. So now we just need to find out our answer. 7.8 times 3, which is going to get us, let's see, 21 plus 2 is 23. 23.4, and this should be positive. A positive 23.4 would be our answer. Different signs will always be a negative. Okay, if you have two numbers, I should say, that have different signs. If you actually have three, it might be a little bit trickier, but -3 times 4, negative times positive is going to be -12. A fraction one here, if you guys have forgotten how to multiply fractions, it's pretty easy. Just multiply the top times the top and the bottom times the bottom. 2 times 1 is 2. 3 times 2 is 6. This is a negative times a positive, so our answer is negative. And we would never leave our answer as -2/6. We would always simplify down to -1/3. All right, so a quick review of multiplication and the rules for that. Now, we've dealt with multiplication. Another little hint for you guys, something to remember, a little trick. This is actually comes from Miss Matheson, who was a 6th grade teacher, math teacher from a couple years back. Same sign, positive, different sign, negative. The way to remember this is love to love. If you love to love, that makes you a lover, which means it's positive. If you hate to hate, that also makes you a lover, which is positive. Okay, if you hate, hopefully everyone in the room hates hate. Okay. Now on the other side of this, if you love to hate, that makes you a hater. That's negative. All right, and if you hate to love, that makes you a hater as well. All right, so we've got negatives and we've got positives. Just a little way to remember your multiplication and division rules. All right, moving right along. Key understanding, okay, the order in which we perform the operations is very, very, very important, okay? Pemdas is a mnemonic device to remember the order in which we perform all mathematical operations, and understanding this order also helps us to solve equations, which is an important skill, all right? Pemdas, many people have heard of this. If you ask your parents, they might even remember Pemdas. The whole please, excuse, my dear Aunt Sally, all right? Stands for those 6 operations. P stands for parentheses. Okay, anything that's in the parentheses, we're going to try and do first. All right. E stands for all exponents. All right. After the parentheses, we'll take care of any exponents and simplify them down to their numeric value. M and D stands for multiply and divide. Right. These are kind of seen as the same thing, just because all multiplication problems can be turned into division and vice versa. And A stands for add and subtract. Subtract. Oops. That's supposed to be a B. All right, so PEMDAS, again, something we review just about every year, and in every math class we talk about it. It's just a sharpening of the tool kind of day here today. All right, now some clarification on exponents. Exponents are actually derived as a quicker way to show repeated multiplication. Very often I will see people do this incorrectly. Now, this whole thing here is the power. 3 to the 4th power is how it's read, okay? The exponent in 3 to the 4th power is actually just this little number 4. This is my exponent, all right? The exponent tells us how many times we're going to use our base, all right? Our base in this case is 3. So 3 to the 4th power means that we've got 3 times 3 times 3 times 3. All right. What I see students do incorrectly a lot is just doing 3 times 4. This is not just a quicker way of writing the number 12. It's actually a repeated multiplication of the number 3. 3 times 3 would get me 9 times another 3 times another 3. This would get me 27 times 3, or the number 81. So 3 to the 4th power, different way of writing 81. Okay, to simplify that is to write it as the number 81. Let's practice a little bit with exponents. You guys can do this on your own in your head if you'd like to, or you can pause the video and you guys can try them out. 4 to the 3rd, this is 4 times 4 times 4. This would get us 16 times 4, or 64. Negative 4 to the 3rd power, a little bit different, but the same concept. This is negative 4 times negative 4 times negative 4. Now, if you think about it, this would get us a positive number, and this would get us a positive 16. And if you take a positive 16 times a negative 4, our answer will flip back to negative. So this is Negative 64 is our answer. Now, if you think about negative 4 to the fourth power, then that would be taking negative 64 times another negative 4. It would flip back to positive. So some interesting things with exponents. We can also take exponents of fractions. 4/5 to the second is 4/5 times 4/5. Top times top, 4 times 4 is 16. Bottom times bottom, 5 times 5 is 25. And if this fraction reduces, we reduce it, but I don't think that that one does. Now, this is a little interesting problem here to look at. 2 to the fourth power with a little negative symbol in front of it. And actually, if you punch this into your calculator, it will get you the exact right answer, which should be a negative value of 16. But if you plug this into your calculator, it'll actually tell you that it's positive. Part of the reason behind that is just our order of operations. We're applying a fourth exponent to the number 2, and then you're just giving it a negative symbol. All right, so this is 2 times 2 times 2 times 2 with a negative symbol in front of it. 2 times 2 is 4, times 2 again is 8, times 2 again is 16 with the negative symbol. All right, so some practice with exponents. I'm guessing you guys have seen them. This is just some review on that topic. Now, the concept of parentheses, why use it, right? Why use parentheses? Well, one way to do this is to change, or one reason why we do this or use parentheses is to change order of operations, right? I want you guys to take a look at the exact same numbers or quantities here, and you're comparing it on the left-hand side with no parentheses compared to the right-hand side, all right? Now that please excuse my dear Aunt Sally tells us what order we should do things. On the left side, we don't see any parentheses, so we would start with the exponent of 3 to the second, which is 9. We'd write that down, 9 times 5, and then 2 in front. We'd then move on to multiplication and division. 5 times 9 is 45, and 2 minus 45 is going to be a negative 43. So you see that with no parentheses, with the exact same number, we get a number of negative 43. Well, if we try that with the second one, when there is parentheses, order of operations says start inside, right? 5 times 3 is the number 15. 2 subtract 15, raised to the second power. Now we do our subtraction. 2 minus 15 is negative 13. And when you square negative 13, you're actually going to get a positive value of 169. So a huge difference between this and this. All right? So that's one reason we're going to change order of operations using parentheses. You can do that. All right? The other reason why we use parentheses is to prevent two symbols in a row, right? This example here, 5 times negative 3, is proper. This is how you should write it. This one here would be improper. Okay, you got two symbols. You got the multiplication symbol, little dot, and then you got the negative symbol right next to it. Not really a proper way of writing things. Another situation where you may not need to use, or may need to use parentheses. Okay. Now, these expressions we're dealing with are just that. They're expressions. They're mathematical sentences that are meant to be simplified and meant to be evaluated, okay? And expressions can either be numeric, which would be just like this one here. Okay, this is a numeric expression because there's only numbers. And they can also be algebraic, right? We'll deal a lot with algebraic expressions that are over here that are meant to be evaluated, okay? Simplified, solved. And if they're numeric, you just need to do the math, right? Please excuse my dear Aunt Sally. We start with parentheses. 6 minus 2 is 4. Write it down. I always think if you're doing this correctly, it's going to look kind of like a funnel. It's going to funnel down. So 4 to the second power divided by 2. We simplify what we can. 4 to the second is 16. 16 divided by 2 would get us our final answer of 8. Okay, so that would be a numeric expression. And to simplify it is breaking it down to its basic most simple way, simple answer, which would be 8 in this case. Now the algebraic expression, notice the difference. We've now got variables, x's and y's, as opposed to just numbers. And when we ask you to evaluate the expression, all we're doing is saying, turn this into something that looks more like that. Okay, turn it into one with numbers. Plug the values in and simplify the expression that you have. So we're going to do that here. 2xy to the second power plus xy. So let's replace x with 4 and y with 2 and see what we get for our answer. So 2, I always like to use parentheses here, times x. X is 4. Times y to the second power. Remember, y is 2 to the second power plus xy. And if you just see the variables next to each other, we imply that it's multiplication. This is x times y. It's not 42. It would be 4 times 2. We've got the expression 4. We've got the number 2. Now we've got the thing into a setting where we can just do the math. We can just do our order of operations. Now, we do see a lot of parentheses here. The parentheses are really just placeholders so that we can substitute the values in. So I'm just going to start with 2 raised to the second power. Write that down. So we've got 2 times 4 times 2 to the second power, which is also 4, plus 4 times 2. Okay. 2 times 4 times 4 is going to start this. Well, 2 times 4 is 8. 8 times 4 is 32. 4 times 2, multiplication there, that's 8. And we simplify this all the way down to the number 40. So we've taken the algebraic expression, we've simplified it by plugging the values in, and away we go. All right, try a couple more here just for practice. Now, fraction bars are another way of showing or kind of using grouping symbols. So you'd simplify the top first and then simplify the bottom if there is any simplification to do, and then see where you are after that. 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 again is 16. So this would get a 16 subtracted by 1 over 5. Well, that's 15 over 5. Final answer would be 3. All right, a little bit more complicated expression with letter B. Same idea though. Okay, we're going to replace A, or anytime we see an A, we're going to replace it with the number 2, B with 4. So we've got 3 times 2 raised to the second power times b, which is 4 on top, minus 2 times 4 times b, or times a, which is 2, all over 4 times the a value of 2, 4 times 2. We've turned the algebraic expression into a numeric expression. Now we just need to follow that order, follow the order of operations. First thing we would start with is this 2 to the second power. So I'm just going to be thorough and write it all down. 3 times 4 times 4. 4 would be 2 to the second. Minus 2 times 4 times 2 over 4 times 2. Do some math here. 3 times 4 is 12. 12 times 4 would get us 48. So on top we would have 48. Minus 2 times 4, which is 8. 8 times 2, which is 16. 48 minus 16 on top. Over 4 times 2, which is 8. Move on to subtraction. 48 minus 16. Well, that would get us what? 32. 32 over 8. Easy enough. Simplifies. 32 divided by 8 is the number 4. We got it. Right. If you guys would like, this can be a last set where you guys can do it all on your own to see if you got the correct answer. So pause the video, try it on your own. There's a little bit more complicated elements to this one just because in the first problem there's some negatives involved. I think you guys can handle it. So pause the video, try it on your own, and I'll work the problem out. All right, we're going to try this. 2 times negative 4. This is a bracket here. This is kind of another grouping symbol. 2 times negative 4 would be negative 8. So inside the bracket, we would have, and on the outside, we'd still have the number 2. 3 minus a negative 8 plus 8. Close the bracket. Now we can work left to right since it's all subtraction and addition. 3 minus negative 8 is the same as 3 plus positive 8. So 3 plus positive 8 is the number 11. 11 plus 8 would get us 19. And this is all being doubled. So we got 2 multiplied by 19, which gets us 38. Now, I'm not sure if anyone happened to do this. I almost did it and I caught myself, but it's tempting to look at that and say, all right, I'm going to do -8 plus 8 first, which is 0, and then add, or take 3 minus 0, which would be 3. If you got the answer of 6, you just need to remember that at this stage, work from left to right. Okay, very common error, all right? But if it's all subtraction and addition, work from left to right. For letter D, if you guys did this one, x squared plus x minus 12 divided by y squared. Again, substitute the numbers first. We've got 5 to the second power plus 5 minus 12 divided by y squared. Y squared is 2 raised to the second power. Start with your exponents. 5 to the second is 25 plus 5 minus 12 divided by 2 to the second power. 2 times 2, which is 4. Next thing we would do is multiply or divide if we have any of those, which we do right here. 12 divided by 4, that's 3. We've got 25 plus 5 minus 3. Now, again, left to right. Okay, all addition and subtraction, we work from left to right. 25 plus 5 is 30. 30 minus 3 is 27. Should be our final. All right. Hopefully the video was helpful for you guys. You're going to get a lot of opportunity to practice it on your own, but this will conclude our lesson on order of operations.